Using tape diagrams to write expressions. For each, draw a tape diagram. Use it to help you write an expression to represent the situation. Number 1, a sum of money was shared between George and Brian in a ratio of 3 to 4. If the sum of money, if the sum of money was $56, how much did George get? So, take a moment, figure out what's important there, and draw yourself a tape diagram that you think represents the situation. So please pause the video now, draw a tape diagram for number 1. Resume the video once you've done that. So let's look at the important pieces of information for number 1. We know that the ratio of money shared between George and Brian is 3 to 4. So since George came first, and also 3 came first, that means George corresponds to 3 and Brian corresponds to 4. All right, so let's think about what that's saying. That's saying if we take the total amount of money that we have, George, for every 3 parts George gets, pretend those are the same size, Brian gets 4 parts. Brian clearly gets the better deal here, right? So even though Mrs. Nichols is being a terrible artist and not measuring and drawing that equally, we can pretend that those are all the same size. So there are actually 7 parts here. And the sum of money was $56. So what I'm doing is I'm taking this $56 and I'm splitting it between George and Brian, but not equally. How much did George get? I can answer this question in a couple ways. I could use the tape diagram to answer. Probably the easiest way. So 56 split into 7 groups is 8 per group. So each of these boxes represents $8. What that tells me is that George, on my blurry camera, George gets 8 times 3 or $24. And Brian gets 8 times 4 or $32. So we know that the answer is 24. That's how much money George gets. I could have also found this a couple other ways. The one I'll show you right now is I could have taken 3/7 times 56. That's probably the most efficient way to get our answer. So 56, that's the total amount of money that we're dealing with. And George is getting 3 of the pieces if we split that into 7 equal pieces, which is really easy to see when we look at this visual. So 56 times 3/7, which ultimately is the exact same thing we did here. We'll get $24 once again. Let's take a look at some more tape diagrams. When I use variables in my tape diagram, I just need to remember that every time a certain letter comes up, it represents the same number. I won't necessarily be drawing this to scale because I don't know if x is bigger than or smaller than 2, for example. So for number 2, representing x plus 2 using a tape diagram, let's say that this is my x. I could represent it as x plus 1 plus 1, or I could draw that out as x plus 2. For the next example, I'm representing 3 times x plus 2 using a tape diagram. So let's think about what that means. I'm taking x plus 2, but I'm taking 3 sets of it. So there's one set. Here's a second set. And then I've got a third set as well. So this is a really great illustration of the distributive property. I'm looking at 3 total sets of x plus 2. And when I lay it out this way, it's really easy to see that 3 times x plus 2, that quantity, is the same as 3 times x plus 6. Take a moment right now to flip onto the next page and look at those tape diagrams on your own. Draw some of those tape diagrams. See what you notice about all of them. So pause the video right now and look at those tape diagrams. Look at the problems that follow this. Draw some of those tape diagrams, please. Okay, hopefully you had some time to draw those tape diagrams. Did you notice anything weird about all of them? If that weird thing is that they all equaled the same thing, then you did it correctly. So each time you should have had 3 sets of x plus y. If I write that out in simplest form, so if I distribute and then combine like terms, you'll find that they all equal 3x plus 3y. All of your tape diagrams should have had 3 x's and 3 y's. They could have been arranged in any order. In my opinion, the easiest order would have been to lay out on a grid 3 sets of x plus y.